In this video, I will talk about how to find equations, or in this video, I will talk about how to find equations given roots of a polynomial. So let's get into it. So let's consider we have a polynomial with roots x is equal to 2 and x is equal to 6 and x is equal to 3. How would you find a polynomial that satisfies all of these three solutions? Well, the first thing we need to do is write it out in its factored form. In order to do that, we simply just have to write it in the form x minus a is equal to 0, where x minus a is a factor of the original polynomial. So for x equals 2, we have x minus 2 as the factor. And for x equals 6, x minus 6 is the factor. And for x equals 3, x minus 3 is equal to 0 is the factor. And now what we need to do is multiply the three factors together, which gives us x minus 2 times x minus 6 times x minus 3. And now what we have to do is expand the whole expression. So in order to do that, we will have to use a distributive property by having x times x and x times negative 6 and negative 2 times x and negative 2 times negative 6. So that will give us x squared minus 6x minus 2x plus 12. Combining like terms, we see that we have x squared minus 8x plus 12. And we still have to multiply by x minus 3. So now we will simply do the same stuff that we did. So now we will simply follow the same step-by-step process we did when we expanded out the x minus 2 times x minus 6. So it will be x squared times x and x squared times negative 3. And negative 8 times x and negative 8 times negative 3. Now it will just be 12 times x times 12 minus 3, or 12 times negative 3. Expanding that out, we end up getting x squared times x is x cubed, and negative 3 times x squared, that is minus 3x squared. And we end up having to multiply negative 8x with x, which is minus 8x squared. And also negative 8x times negative 3, that is plus 24x. And now for the 12, we will have plus 12 times x, which is 12x, and 12 times negative 3 is negative 36. So now we'll just combine like terms and look at the expression we get. So we have x cubed minus, and here we have 11x squared, and then 24x plus 12x is 36x, and it's minus 36. So that's how you find a equation given real roots. Just write it out in a form that you have the factors and you just expand the whole expression out. So now let's go ahead and look at another example, or in this example, we will have complex roots. So we have x is equal to 3 plus 6i, and x is equal to 3 minus 6i, and x is equal to 1 plus I, and x is equal to 1 minus I. We just follow the same process we did in the last example, so we would have our factors of x minus 3 plus 6i is equal to 0. So we have x minus 3 minus 6i equals 0 for the second factor. For the third factor, it is x minus 1 plus I is equal to 0. And for the last root is x minus 1 minus I is equal to 0. So let's go ahead and start off by expanding the conjugate pairs. So we will multiply first x minus 3 plus or minus 6i. And then similarly, we will expand the last two solutions, 1 plus or minus I. So let's go ahead and start by looking at x minus 3 plus 6i times x minus 3 minus 6i. And we will simply just expand the whole expression by using the distributive property, which is x times x and x times 3 minus 6i. And 3 plus 6i times x and 3 plus 6i times 3 minus 6i. And after expanding that, we will get x squared minus 3 minus 6i, all multiplied by x. And then we will end up having minus 3 plus 6i times x and plus 3 plus 6i times 3 minus 6i. Combine like terms first, we will end up with x squared minus 6x because the imaginary counterparts will cancel out as they are conjugates, so they will go away. So we end up having minus 6x, and now we just simply have to expand the conjugates. So 3 times 3, that is 9, and 3 times negative 6i, that is minus 18i. And now we also have 6i times 3, which is positive 18i. And we have 6i times 6i, so which is 6i, or 36i, I squared. So the imaginary counterparts will cancel out, and we are left with 9 minus 36 I squared. I squared is simply negative 1, so it is 9 plus 36. And we have 9 plus 36 is 45. So we have minus 6x plus 45 is equal to 0. So we have found our first equation just from multiplying out the conjugate pairs. And for the second expression, we will have x minus 1 plus I times x minus 1 minus I. Expanding the expression, we end up with x squared, since x times x is x squared, and x times negative 1 minus I, that is minus 1 minus I x. And similarly, we have negative 1 plus I times x, and we have plus 1 plus I times 1 minus I. The left-hand side with all the x's will give us x squared minus 2x. And here we have to multiply the conjugates out. We have 1 times 1, which is 1, and 1 times negative I, which is negative I. And I times 1 is I, and negative I squared is negative 1. So here we have that this cancels out. And we have 1 plus 1, which is equal to 2. So we have plus 2. So you have both of our quadratics now. So now what we simply can do is expand these two quadratics by multiplying them together. So we have x squared minus 2x plus 2 times x squared minus 6x plus 45. So we will have x times x squared and x times negative 6 and x times 45, or x times 45, giving us x to the 4 minus 6x cubed and plus 45x squared. And then we will have 2 or negative 2x times x squared, negative 2x times negative 6x, and negative 2x times 45, which will give us negative 2x cubed plus 12x squared and minus 90x. And now what we will simply do is go on and multiply the constant with everything else. So it's 2 times x squared and 2 times negative 6x and 2 times 45, giving us 2x squared minus 12x plus 90. So now what we have to do is go on and add everything from top to bottom. So we will end up with x to the 4 minus 8x cubed plus 59 x squared minus 102x plus 90. So the polynomial that has all of these four roots is x to the 4 minus 8x cubed plus 59x squared minus 102x plus 90. And it is just a matter of expanding out the expression that you are given. So if you want to find equations given roots, just convert it into a form that you could rewrite them all as factors and just expand the whole expression out to get the original problem or polynomial. So hopefully that was a easy to understand process, and hopefully you learned something with that.